Quantum computing has been a major research topic for multiple companies the past few years, with Wave, IBM, and Intel all launching their own systems and improving them at a fairly rapid clip. At SEI 2018 this week, Intel's CEO, Brian Krzanich, declared the company's new 49-qubit quantum computer represented a step towards quantum supremacy. A 49-qubit system is a major advance for Intel, which just demonstrated a 17-qubit system 2 months ago. Intel's working with the Netherlands-based Quitek on this project, and expanding the number of qubits is key to creating quantum computers that can dare real-world results. When Intel launched its 17-qubit system in October, it wrote, "Qubits are tremendously fragile. Any noise or unintended observation of them can cause data loss. This fragility requires them to operate at about 20 millikelvin, 250 times colder than deep space. This is also why we won't be seeing quantum computers in anyone's house at any point." While early classical computers were also room-sized and required commensurate cooling solutions, there's no known way to build hand-sized or even desktop quantum machines that incorporate the cooling required. Intel Corporation's 49-qubit quantum computing test chip, codenamed Tangle Lake, is unveiled at 2018 SEI in Las Vegas. Credit Walden Kirsch. Intel Corporation. Intel didn't disclose many specifics about its current machine, but it declared its 17-qubit system was built on a different architecture for improved reliability and thermal performance, use a scalable interconnect that allowed for 10100x more signals into and out of the chip, and incorporated advanced processes and materials to allow Intel to fab the microprocessor in the first place. Presumably, all those features are still baked into this system. The new system is codenamed Tangle Lake, a reference to an Alaskan lake chain and the tangled state of the electrons themselves. Quantum computers are extremely different from standard classical computers, and can tackle problems modern classical machines can't handle. The reason increasing the number of qubits in the system is important is because it also allows for a significant amount of additional work to be done, and for more complex problems to be considered. And according to Intel, the gap between where we are today and where the company thinks we need to be for commercialization of quantum computing is enormous. In the quest to dare a commercially viable quantum computing system, it's anyone's game, said Mike Maybury, corporate vice president and managing director of Intel Labs. We expect it will be 5 to 7 years before the industry gets to tackling engineering scale problems, and it will likely require 1 million or more qubits to achieve commercial relevance. Intel is also investigating another type of qubit, spin qubits, to see if they can be implemented in silicon. Spin qubits are much smaller and can potentially be implemented in CMOS, and Intel has invented a spin qubit fabrication flow on 300mm process technology. This is oddly phrased, but seems to indicate Intel is building these chips on its 300mm wafers as opposed to some new process node.